Imagine a world where robots don't walk like humans but scuttle, slither, and soar like the creatures that inspired them. From the sticky toes of geckos to the flapping wings of birds, engineers are turning to nature's greatest designs to overcome challenges in mobility, adaptability, and energy efficiency. Today, we explore 4 cutting-edge creations: SmartBird, Charlotte, Sport, and the Kawasaki Kolio, and uncover how biomimicry is rewriting the future of robotics. SmartBird, taking flight with nature's blueprint. The aha moment for SmartBird came when its creators watched a gull in flight and wondered if they could replicate its effortless gliding. What emerged is a robotic bird with a wingspan of nearly 2 meters, powered by a lightweight carbon fiber skeleton and an electric motor that mimics real bird musculature. SmartBird doesn't just flap, it adjusts its wing shape mid-flight to bank, dive, and soar with astonishing efficiency. Its silent, graceful arcs demonstrate that nature's aerodynamic secrets can unlock sustainable, energy-saving flight for surveillance, environmental monitoring, and beyond. Charlotte, the spider that scales new heights. Picture a giant mechanical spider scaling walls and ceilings as if gravity were optional. Built by Crest Robotics and dubbed Charlotte, this 8-legged marvel uses specialized foot pads that alternate adhesive and release phases, just like a real spider's tarsi. Charlotte can navigate glass, brick, and even uneven rock faces, opening possibilities for search and rescue missions in collapsed buildings or inspection tasks on wind turbines. Its architecture distributes weight across 8 limbs, ensuring stability on precarious surfaces. Charlotte's uncanny ability to walk where wheeled and legged robots struggle shows how lessons from arachnid anatomy can revolutionize terrain traversal. Boston Dynamics Spot, the all-terrain quadruped. Boston Dynamics Spot marries sleek design with rugged versatility. Modeled loosely on a dog's gait, Spot moves fluidly over rocky paths, grassy fields, and industrial floors. Its powerful actuators and dynamic balancing algorithms let it recover from pushes, climb stairs, and even dance, proof that animal-inspired mechanics can yield both agility and resilience. Equipped with cameras and lidar, Spot can autonomously map environments, inspect hazardous sites, or simply carry payloads that tire human workers. As a flexible platform for research and industry, Spot exemplifies how quadrupedal locomotion can unlock new frontiers in robotics applications. Spot has also been used for inspection tasks on oil platforms, like the SCAV floating production storage and offloading vessel. It's inspected buildings in construction zones, mapped indoor terrain, and even patrolled public infrastructure. In February 2024, drivers on the M5 motorway in England were warned not to panic if they saw a Spot robot walking by the roadside. It was being trialed by the National Highways Administration as an alternative to human inspectors in high-risk areas. Kolio, riding the future like a mechanical wolf. Bridging human intuition and animal grace, Kawasaki's Kolio reimagines personal transport as a rideable, four-legged robot inspired by the lupine gait of wolves. Fueled by a hydrogen fuel cell paired with a compact 150 cubic centimeters engine, Kolio generates electricity to power independent actuators in each leg, giving it unmatched mobility and adaptability across diverse terrains. Riders mount Kolio much like they would a horse, using subtle shifts in body weight to steer and control the robot's movement seamlessly. Its split rubber hooves actively conform to surfaces like grass, gravel, and rocky paths, providing excellent grip and stability in places where traditional wheeled vehicles struggle. What truly sets Kolio apart is its shock-absorbing leg suspension system, which enables smooth walking, running, and even climbing over obstacles, mimicking the natural rhythm and balance of a wolf navigating wilderness terrain. The robot's onboard heads-up display projects key data, such as hydrogen fuel levels, balance indicators, and suggested route markers, directly onto the ground in front of the rider, enhancing situational awareness without distraction. This fusion of biomimicry and cutting-edge technology promises a new kind of transportation that is not only efficient and eco-friendly but also incredibly intuitive, allowing humans to connect with their machines in a way that feels as natural as riding an animal across untamed landscapes. Kolio is a vivid example of how animal-inspired design is expanding the possibilities of robotic mobility and personal freedom. Why biomimicry matters. Nature has spent hundreds of millions of years optimizing movement and energy use. By studying creatures, from geckos that defy gravity to fish that slice through water, engineers can leapfrog traditional design constraints. Animal-inspired robots boast enhanced mobility. Multi-limb systems and compliant structures adapt to irregular terrains. Energy efficiency. Passive dynamics and shape-shifting components reduce power consumption. Environmental integration. Quiet flight and gentle contact limit disturbance to wildlife and people. Translating biological complexity into robust machines isn't trivial. Adhesive mechanics degrade with wear, soft materials remain difficult to simulate, and real-time control of dozens of degrees of freedom demands advanced algorithms. Yet rapid advances in materials science, machine learning, and miniaturized power systems are closing the gap. Future animal-inspired robots could swarm like schools of fish for underwater mapping, burrow like moles for subterranean exploration, or even leap like frogs to traverse rubble-strewn disaster zones. As the boundaries between biology and robotics blur, the machines of tomorrow might move not like us, but like the astonishing creatures that share our planet. Whether flitting through the sky, clinging to skyscrapers, or bounding across rocky terrain, animal-inspired robots promise to transform industries, aid humanity in perilous environments, and inspire us to look to nature for our greatest technological leaps. The wild world is our blueprint. Let the adventure begin.